firstly, let me introduce myself. I'm Stephen Pickering. I'm the general manager for B Meters UK. It's a country location of B Meters SRL, the manufacturer of water and heat. Most of you probably have used our meters in some respect or some form or fashion. But to just give you a little bit of insight on the company as a manufacturing state, and then a little bit of an introduction onto B Meters UK and how we differ from the factory and how we support the companies in the UK. So the first slide is essentially just introducing the company. It's over 30 years of manufacturing in water meters. Predominantly, the company produces over 2.2 million meters per year, with products distributed in more than 90 countries worldwide. B Meters operates both nationally and internationally, supplying water utilities, industrial clients, and the private market. Today, the range includes water flow, smart meters, heat cost allocators, as well as direct reading, remote reading, smart metering solutions as a whole. The company facilities, when I first started in 2019, it was predominantly the plant number 1 and a little bit of plant number 2. Since then, they've demolished a number of warehouses and created a brand new electronic production and warehouse. B Meters as a company focus on design, metrological verification, automation, and certified quality. Everything is done around MID approval. So the standard for billing across Europe and worldwide, working obviously in 90 different countries. There's a lot of local regulations as well. So everything that everything we produce as a company comes with the highest level of I suppose competence as you can imagine. One of the benefits of B Meters and one of the best things working for B Meters is that the product design and engineering is a key focus. So water meters in general are, I would say, not necessarily a huge upscale market. For example, a lot of the water meters 10 years ago haven't really updated. A lot of them rely on still, classic read-switch pulse outputs, for example. B Meters take 10% of their annual revenues and invest it into research and development. And since I've started in 2019, that has meant 5-6 new product lines. It's also meant upgrades to product lines, such as new technologies once they come out and there's a market for them. As I've already touched on, all our mechanical electrical parts are designed around MID, so the standard for billing, as well as obviously design and research and development. The automation process within the factory is astonishing. Almost everything within the manufacturing of the meters that we offer comes along a production line, and this is something where that's allowed the production capacity to grow tenfold. Again, when I first started B Meters, this was really coming into focus. So that it was still a reasonable size operation, but when you look to what it is now, it's just night and day. It's really it just means that the lead times that we're able to meet, the demand we're able to meet is alongside the best metering companies in Europe and worldwide. Everything that we produce, so every meter that's whether it's a single jet, multi-jet meter, everything is tested and verified. So whether it's as I said, whether it's a small single jet water meter or a bulk DN200 meter, You can get the accuracy certificate, you can get the MID certificate, and anything else that you may require from consultancy point of view or just a verification point of view. And all our testing and processes are all certified. ISO 9001, 14001, as well as our test benches are designed for our test benches are designed purely for verification, so it doesn't have to be our products. They are used for partner product lines for verification purposes. There is six with ourselves branches in and around Europe. So Gunars, Italy is the headquarters. Madrid, Spain, Poland, I can't pronounce that. Budapest, Hungary, Romania, Bucharest, Stockholm, and obviously Birmingham, although it was Nottingham when first set up, which is where I'm from. The last documented sales that we've produced as a company, as a whole, we produced 2.2 million water meters, 600,000 communication modules, 90 countries served, 110,000 thermal energy meters, which is a smaller part of B meters, but very much still significant. 110 employees in Italy, which mainly around the production and facilities, and then 170 employees across Europe. Now, to introduce B meters UK and how we differ from B meters SRL, we started off as essentially a shop front for B meters SRL. That meant was after Brexit, they wanted a location within the UK that would stock, serve, and supply B meters products. Avoid any undue duty. At the point that this was all conceptualized, there's still no control on what Brexit could look like. So that's how B meters UK was born. Since then, we have expanded the product portfolio to cover thermal water, obviously thermal energy, gas, electricity, and mixed fluid, as well as a complete range of smart metering systems and remote reading solutions. So what we try and do is provide the best-in-class meters with the best-in-class solutions to allow integrators and installers to have access to the best possible solutions on site. We've done this with our technology partners. Some of these you may know, some of them you may not, but Landis+Gyr, Geniers, Milesight, Netmore, Eastron, and Emu Electronic are all partners with ourselves in some respect. Some on the metering side, so Landis+Gyr is the go-to heat meter that we tend to offer. Emu Electronic are engineers or more M-bus infrastructure. Milesight, obviously, for the LoRaWAN. Our association with the BCIA and its members, it probably started before so, but was a full member in 2020 and the first metering company to be inducted. We've previously been nominated for Technical Innovation of the Year with our hydrosonic water meter, although lost out. I can't remember what to now. And technology partners of numerous BCIA members. So, and I know a couple of them here. So, UK Electric, Sante, and Synapsys Solutions, namely. Right. So, as I went to get into the topic for this lunch and learn, I wanted to focus predominantly on wireless communication and integration. However, in order to get to that point, I realized that there needed to be applied context. So I wanted to just go back and layer every part of a metering solution up to the point of integration. So the first one, meters and approvals. We are obviously, as I've mentioned, we offer a comprehensive portfolio of water, heat, cooling, and gas, electricity meters, and all of these are designed around MID approved devices. Ensuring trusted accuracy, legal conformity, blah blah. It's this is where the presentation really takes off. So one thing that is important is the classification and the certification of particular meters. So, for example, water meters, the MID certification is MI001. The classification is R40 up to R800. That could be as high as R1000 now, I believe. Gas meters, MI002. So a different MID certification. This is just purely to show that you can't use a gas meter to monitor water and certify it for billing. Obviously, you never would. However, in the past, there has been MI001 water meters used with heating systems, and that's partly the reason why I wanted to bring this up, because the MID certification, the classification, is important when it comes to ensuring that you have the most, or you have the correct product for the application. So electricity meters are MI003, classification class A, B, or C, and heat and cooling thermal energy meters, MID classification, MI004, classification 1, 2, or 3. And along with these, you may get asked for other standards. For example, water, heavily linked to RAS approval, KIWA, Water Authority 4, and then the standard for MID, which is the BSEN ISO 4064. The same on the gas, although the IGEM GM6 edition 3 is more to do with how gas meters are safely installed. Same with electricity meters. And heat and cool EM 1434 compliance will always be linked to MI004. So that's something that will come up time and time again. I'm trying to understand where. So just focusing firstly on water meters. Water meter solutions have a diverse range of technology designs, and they are designed for varying flow conditions, varying installation types, and the performance requirements that are required, again, across domestic, commercial, industrial applications. So, for example, the most common meter that you may see on site is a single multi-jet water meter, and the ideal use case for these, domestic light commercial applications. These meters provide a reliable and cost-effective measurement for low to medium flow rates in residential properties and small buildings. Then the next size up for your bulk meter requirements, designed, the Waltman, designed for high volume commercial industrial use. Waltman meters are suited to bulk water measurement where consistently high flows and durability is essential. Rotary piston, manifold water meters. These are typically used in utilities and for residential use only. The design is slightly different. You may see these predominantly with Tennant valve assemblies. These are excellent at offering high accuracy at low flow rates, which is why they are predominantly used in the utility market in the UK. But they also are used in multi-occupancy buildings where precise measurement and compact installation are required. And then the most modern form of technology in water meters is ultrasonic, advanced, maintenance-free, suited to a wide range of applications. The size and range of ultrasonic water meters can go from anything from DM15 up to 300, and the turn down ratio dynamic range, which we'll get to, is much more advanced than you can get with a mechanical water meter. So, as I mentioned, MID certification quite a lot. I just thought it'd be a good idea to put a slide on that really highlights how it works within water. So, you have a minimum flow rate, which is your Q1. You have your permanent flow rate, which is your Q3, and you also have a transitional flow rate, which is Q2. Now, the dynamic range relates to how the Q3 relates to Q1, and within these parameters, you have to have at least a plus or minus 5% between Q1 and Q2, which is your minimum and your transitional, and plus or minus 2% between your Q2 and your Q3, your transitional and your permanent. So this is where different meter types have different MID classifications. And then this is something that you may get asked for and you may adhere to. So for example, if you've got a single jet water meter in the mechanical dry dial type, the maximum you are likely to get is R200. The standard tends to come in around R100. If you've got a digital dial single jet turbine, again, you can get really good accuracies. You can get this as high as R400, as shown by a Hydrojet S1. Same thing on the GMDMI and the Hydrojet, which is your multi-jet meters. Same on the Wallman meters, and then it varies when you get to the ultrasonic water meters, because these are really able to have much better accuracy at lower flows. So in an ideal world, you would go ultrasonic for everything, because you're not going to be moving parts, you're not going to lose accuracy. The accuracies are going to be better over the time length, the lifespan of the meter. There is no jeopardy with installation positionings. For example, multi-jet meters you can't install typically with a dial facing down. But obviously you are, as an installer, always looking for cost-effective options, and ultrasonic meters are just more expensive. Now the price is climbing down as technology develops, and you do get the option of efficiency, volume, allowing for the price to come down. But mechanical water meters will always have a place in the market. They are stellar proof of billing. Most systems are designed around an R100 meter being more than sufficient. So it's not necessarily something that it's something that you may see in a specification, but as an installer, it's not something I tend to overly worry about. Now, heat and cooling meters tend to be a little bit different, because the variation comes on what type of site and what type of requirement. So, for example, residential apartment billing, the typical meter would be a compact ultrasonic heat meter, DM50 and DM200, like the Landis+Gyr T330. Very cheap, very cost effective, meets the requirements, and has a good, robust lifespan. So, even battery powered, you'll get 11 years out of these meters. And if the batteries need replacing, they on the newer versions they can. The approval requirement is always going to be MI004 EN 1434 compliance. That doesn't really change. So whereas water has a little bit more variation on, okay, we may need a higher classification, all heat meter manufacturers tend to try and meet the same standard, which is MID class 2. So all ultrasonic, Camstrup Deal, Itron, Landis, they all tend to be MID class 2, EM 1434 compliant. So as you go through it, it's the different types. So, for example, you've got a Landis UH50 for commercial buildings, which just has a much more varied range. So you can get DN15 up to DN300 up to, if required, 500, 600. District heating and cooling, again, very similar. There may be a requirement for more wireless communication within district heat, and we'll come on to that a little bit later. And industrial and plant room applications, again, typically you're just looking at the every single meter in this slide has the same approval. It's MID Class 2. The difference is the type of communication it offers, and the size. So it's not something, from my point of view, I would always recommend, depending on your application, depending on your project, what you'll likely find is one manufacturer will have much stronger commercial benefits in some respects than others. And that's because manufacturers tend to specialize in certain areas. For example, Landis+Gyr will always be very strong in the compact ultrasonic meter market. You know, that's where they tend to pick up the bulk of their business. They are one of the leading, I think, if not the leading manufacturer of metering products worldwide, certainly in the UK. With their gas and electricity business, but on the heat, they a lot of their designs are based on residential, whereas you may find that Camstrup and others are specialised in more commercial industrial applications. So it really does just come down to what type of project do you have, and what type of price point do you need to get to, because every manufacturer will be able to meet the same classifications of the same standards. So it comes down to installer preference. On gas, just quickly run through gas meters. These tend to come in, again, different types, a little bit like water meters. You've got diaphragm gas meters for residential, turbine for more commercial industrial, rotary again for the more commercial industrial. However, rotary gas meters typically, and you can get MID approved turbine meters, but they're not as common. Whereas rotary gas meters by design are MID approved. And lastly, again, more modern technology, ultrasonic gas meters. So I just wanted to leave this slide up to just go through, whenever you've got a gas application, the type of meter will always denote by the flow range and the variability in that flow. I know a lot of installers will typically prefer to install turbine gas meters. They're much easier to work with. However, in a lot of cases where the flow rate might fall below the minimum of turbine gas meters, diaphragm gas meters are still very cost effective and economically viable. Whereas obviously rotary gas meters can work at lower flow rates. However, the cost is definitely more prohibitive. So it just depends on the application and what solution you tend to go with. So now we've looked at the water, looked at the meters as a whole. The next layer that I wanted to look at was the metering communication. So I wanted to look at the main ones. I know there are a few others out there, but Pulse, M-Bus, Wireless M-Bus, LoRaWAN, BACnet Modbus, RS485. So Pulse output, and he probably never thought you'd see a slide dedicated to Pulse outputs. But again, I thought this would be quite important just to go through the varying Pulse outputs that are available. So you have simple, dry reed switch Pulse outputs. The pros are low cost, simple and widely compatible, no power supply required. You may see these still these are still regularly used in submetering. Ultimately, any company importing from outside the EU are typically going to be using these. This is a communication protocol because it is cheap and easy to use. More modern metering manufacturers that still use Pulse outputs are likely to use open collector. So most Pulse outputs on heat meters, for example, will tend to be open collector. More meters that you you associate with the utility markets around Europe, such as BME, Itron, Elster. They all, where they have a pulse output SSI, but it's an open collector pulse output. And the pros of the open collector running in the face of the cons on their reed switch pulse output. So reed switch pulse outputs are limited life due to canonical wear, slow switching speed, sensitive to vibrations and shocks. Ultimately, if data is important, the reed switch pulse output is just not going to cut it long term. It will work, it will serve a purpose, and it's very easy to work with, but it won't give you the reliability over the length of the meter. Open collector pulse outputs are much more robust, much better to that. They have higher switching speed, good signal stability, and reliable solid state operation. The downsides really are installation and commercially. They are, because there is more functionality, there's more to it, and they're more expensive than reed switch pulse output. And I say they're slightly more complex in terms of wire and configuration. For example, our PL3s have an app where you can set the pulse values. It works via NFC. It can be a bit fiddly, but it's nice and easy to set up. And the difference is you just have to get the polarity correct with which cores you're using. And Hall effect sensors were quite commonly used. Again, maybe before the burst of open collector pulse outputs. They were essentially what the reed switch was, with external power to it, so it had a much higher level of stability, a much higher level of reliability. However, when researching for this presentation, I found that most of the Hall effect sensors that I had been aware of have switched to open collector. So these are becoming more and more phased out, I would say. And lastly, active pulse outputs, which you'd likely find on the Siemens MagFlow meters, for example. And these are best in class. They're strong signal, suitable for long cable runs, high accuracy, fast response, less noise and interference. The downside is it requires external power supply, higher cost for sure, and complexity. And you need something that can align, can pick up an active pulse output, whereas open collector and reed switch pulse outputs are just much more commonly used. For mechanical meters, active pulse outputs just wouldn't ever be a solution, whereas obviously open collector is found a place in the market. Moving on to wired M-bus, which again I imagine most of you, if you get involved in metering, is probably your go-to across water, heat, and even if you're taking pulse outputs and converting them, M-bus is an easy easy communication to work with. An ideal application would be single building-based metering system where reliability, scalability, and low maintenance are points of emphasis. So, for example, against a pulse output, you tend to get very restricted cable runs with M-bus. You essentially run a bus, daisy chain onto it, and then you can pick up multiple meters on the same network. So it's not fixed to any one manufacturer or to any one device. Most metering manufacturers will have an M-bus solution. Most of them will work with third-party devices. So it's very open protocol. The pros supports up to 250 devices, although with repeaters that can be more. The power and data of one cable, so you don't have to run an external power to it. The bus does the bus typically powers the network. And on our water meters, for example, the modules are supplied with a backup battery, but they are in essence powered by the M-bus network. So in theory, should run as long as the network does. It's low maintenance and reliable, robust communication. Now, for the cons, it tends to come down to just cabling in general. So it's not ideal for widely spread out rural properties. For example, going from building to building can be a bit of a nightmare. Work will in retrofit where cabling is difficult, and temporary or mobile installations. And a point of emphasis is classic MBUS does not include built-in encryption. There are notable technology developers I wanted to give a shout out to. So Alvaca, Relay, Engineers, Emu, and Synapsys all have MBUS technology, devices that interface with MBUS technology, masters, repeaters, etc. So these are the ones that came to mind when I was setting up the presentation, just to obviously give you an idea of who is creating who's creating the technology out there. BACnet and Modbus, again, will be a preference for BMS engineers for sure. Again, systems will vary by application setup. Typically, these are saved for more complex installations where real-time data is required, and you want to avoid any interfacing between the meters and the overall system. So one example that came to mind straight away, again, it's becoming very popular, is data centers. So I imagine any specification for heat meters in general in a data center is going to come to BACnet or Modbus communication. Pros and cons. Pros, again, very straightforward. Flexible integration, real-time data access, supports large range of device sensors, scalable and adaptable. On the other side, not ideal for simple low-cost residential metering for sure. BACnet and Modbus, you don't get it on mechanical meters. The devices require an external power supply, so BACnet not so much, but Modbus you will see on obviously electricity meters, ultrasonic meters, mag flow meters, but the standard classical mechanical water meter is definitely not. And this is where you again incorporate converters. It takes skilled integration with guys such as yourselves to get the full functionality, network performance dependent on design, configuration, and traffic management. And as with MBUS, another obviously part that I wanted to touch on was classic Modbus and BACnet don't include built-in encryption. And again, just to give a shout out to some of the technology developers, ISMA, obviously with the ISMA gateways, Tritium with the overall edge system, Synapsys, Intensys, Engineers. Again, they're the ones that came to mind. There are plenty out there, and the interface side of things, obviously, you guys will know much better than me. So I've mentioned on encryption there, and this is a point of emphasis I wanted to come on. So there's a GDPR consideration. And this is because Ofgem and the UK smart metering framework treat most metering consumption data as personal data. So where you have a meter in an apartment and that meter is communicating outside of the dwelling, it is actually treated as personal data. This means organizations must ensure appropriate technical and organizational measures are in place to protect data. When personal data is transmitted, it must be protected against unauthorized access or interception. Smart meter and consumption data can reveal behavioral patterns within a home. That's the reason for the sensitivity. Encryption is a key method to use to safeguard personal data. So this is why at the moment we're seeing a lot of push towards encrypted metering communication. Does this mean the end of wired meter communication? No. When you actually read the HENTAS meter monitoring standard, the draft states, systems not capable of encryption shall be protected by the most robust physical or other security measures to prevent unauthorized parties from accessing usable personal data. So it's essentially saying you can have non-encrypted data, however, they need to be, it can't be easily accessed in common spaces. For example, with an MBUS master, you could, if there wasn't a cabinet, if it wasn't locked, if there wasn't a physical security measure, you could essentially link a MBUS master to that network and get their personal data on it. Same with Modbus, same with BitNet. Again, 2.2.36 is just the systems not capable of encryption shall demonstrate the adequacy of their compensatory security controls by means of an independent security controls assessment. Technical scope is all about ensuring meter accuracy and data integrity. So it's not about having encrypted data; it's just having the data secured. However, going forward, if it was my advice, I'd say if meter data leaves a property and can be linked to a dwelling, just treat it as personal data and encrypt it. We have the wireless communications now available to us. They're very easy to integrate with, very easy to use. In the past, obviously, wireless MBUS has realistically been the only solution. Now we've got LoRaWAN, and obviously the infrastructure with it around LoRaWAN means that you can have systems on very small scales supported by LoRaWAN or wireless MBUS. And when you've got like a multi-building system, that's where LoRaWAN really takes preference. So I just wanted to obviously touch on both protocols. Wireless MBUS systems are selected based on coverage requirements, installation constraints, and data needs, with mobile walk-by and drive-by solutions commonly used for smaller residential retrofit schemes, fixed network architectures deployed across larger building developments to enable automated and continuous data collection. An extended range of wireless configurations supporting robust long-distance communication for remote monitoring, billing, and integration with energy management cloud-based platforms. So an ideal application for wireless MBUS is either a small single dwelling building where you can easily power repeaters, or a small estate. Like this one in the picture, this is one that we worked with on one of our technology partners, and they did water, heat, and electricity all via wireless MBUS. The pros and cons, again, very, very simple, scalable networks. If you have the right access to the right infrastructure, you can. The repeaters are very cost effective. So wireless MBUS repeater is very cost effective. Always try and buy a powered version, so I have a 24 volt, 230 volt, just because battery powered versions can die very quickly, especially on a site with multiple meters and multiple repeaters. It supports multiple utilities. So again, water, gas, heat. Even if you don't have a wireless MBUS direct from the meter, you can usually easily find a port to wireless MBUS converter. Data accessibility enables easy integration with billing, monitoring, and analytics platforms. And the key point of emphasis is secure communication. It supports AES 128 encryption for device protected data transmission. The cons tend to, especially on wireless MBUS, tend to come down to the range limitations. So signal interference can be a nightmare. It affects performance. Performance is affected by building structure, density, and RF noise. Range limitations typically requires additional repeaters, concentrators. And as I said, if you're working with the wireless MBUS system, repeaters are almost a necessity. There's no way that the meters will allow for the coverage. And obviously, as you scale up, you get potential data collisions, which is the same with any wireless communication. Technology developers is an interesting point. There aren't too many third-party developers of wireless MBUS infrastructure. So you will find, for example, BMeters have their own, Camstrup have their own, Sontex have their own. A lot of manufacturers will have their own devices, but you don't find too many that are that sit outside of a manufacturer of a meter and create solutions. These typically fall between Elvaco, Engineers, and Relay, three of the most dominant in terms of M-Bus and wireless M-Bus infrastructure. LoRaWAN, obviously, I imagine most of you have used LoRaWAN before, and you probably know it inside out. So I just thought I would go through LoRaWAN in terms of metering communication. These systems are effectively configured around range, power efficiency, and data accessibility requirements. It's so easy to go from a sensor to gateway deployment in smaller retrofit, but these can be scaled up very quickly. And I think going forward, any metering project that is going to require some scalability, LoRaWAN is going to be, right at the front of it, because you don't get the scheduled, the real-time data as you want. A lot of it is scheduled, especially when you're working with mechanical meters, just because they have to preserve battery life, if they aren't externally powered. But even so, you can get uplinks. You can get payloads sent on a very consistent basis. So it just depends on your requirements. So again, the ideal application in the heart, in comparison to everything else, is going to be large multi-building, where remote data collection are key priorities. Pros and cons: long range wireless communication supports reliable data transmission over several kilometers. Low power consumption. Again, you don't need external power. These can be battery powered, and the battery powered devices can last for anywhere up to 10 to 15 years. Open ecosystem. It's not just different meter manufacturers like it is with wireless M-Bus. This embodies all different types of sensors, devices. It's just the range of LoRaWAN products and devices out there at the moment are insane. So it won't be long that I'm absolutely sure that you'll be able to do complete projects just based on the LoRaWAN backbone. You get adaptive data rates. As I said, it's not just not one payload an hour. You can get minute data, and the important thing, as we've already discussed in terms of GDPR, secure communication. So it supports AES 128 encryption. The cons: latency constraints. Data is typically sent at scheduled intervals rather than continuous. Better for monitoring than real-time control. Network dependency. Performance relies on gateway placement and network design. Coverage, variability. Signal strength can depend on terrain and building density. Some of the notable technology developers in this area, some of them obviously Marsight, a key proponent, Sante, one of the most prominent BCIA companies that have taken it on and really grown it within the group, within the network. Curlink for gateways, we see a lot of WattSense and Netmore for an overall sort of LNS. But there are so many technology developers and systems out there that it is, and it's growing so quick. So depending on how you typically like to work, you by all means, I would look at LoRaWAN as a solution and see, okay, what can it do for me? And if there isn't a solution out there already, I imagine it's not too far away. So now we've looked at metering communication. I just wanted to run through something that would probably open a few people's eyes that don't necessarily get involved in metering too much. So I just wanted to consider something as simple as a 20 mil cold water meter. And it's easy to assume that all the device does is deliver the same basic function, which is metering consumption. However, the choice of communication protocol and style can have a significant effect on the data that you receive. So a read switch pulse output, dry contact. The information available from that is consumption data. It has one cycle. So on this one, our GSD8 water meter, for example, it does 1 liter. It makes a contact. and then it obviously sends the information. So the only thing you can defer from that meter at the point of the meter is the consumption data. Obviously, once you add it to a controller, you can get flow rate information, and you then use the pulse output to its full potential. However, as we've discussed, reed switch pulse outputs aren't necessarily the most um, reliable. So again, if data is important, it's not something I would particularly promote. The open collector, for example, which is again the same type of output, pulse output, information available, consumption data, but you also can configure the unit to give you backward flow data. And along with that, you do get certain alarms. So module removal alarm, ducted tampering alarm, cable cut alarm, magnetic tampering alarm. So if you're working in, obviously if this is a sub-metering, if this is being used for sub-metering and revenue revenue generation, all these alarms are built to obviously give you insight into, okay, is this being tampered with? Now we go to M-Bus and wireless M-Bus. You get obviously a lot of the same features as you would from an open collector pulse output, but you also get a variation alarm, such as leak detection alarm, low battery alarm, burst alarm. So because it sits on a meter, it knows what meter it's sat on. It can tell you, okay, it's seeing constant flow for 6 hours, so it sets a leak alarm. With battery, obviously, if it's wired M-Bus, it'll be likely powered by the M-Bus network. If it's wireless M-Bus, obviously, it's going to be battery powered. Same with the burst alarm. If it sees a huge influx of flow and the Qmax on the meter has been overlapped for 10 minutes, it will give you a burst alarm to let you know that obviously there's a issue within the system. As well as that, you get primary and secondary address IDs and manufacturer ID. Now, LoRaWAN. You get everything available on M-Bus and wireless M-Bus. In fact, most of the infrastructure for LoRaWAN is based off the M-Bus backbone. But you also get, because the payloads can be larger, you can get more information. So with our hydrodigi meters, for example, you get the size of the meter. The medium is working with firmware version. You get new alarms and quantifiable data. For example, this meter's had no consumption for X amount of days, or this leak alarm has been running for X amount of hours. And on the latest firmware, you can get historical values, 16 delta hourly values for the last. So because there is no limit to the payload it can send, I think it's 51 bytes will allow you to see a historical value. So you get one payload and you can see the last 16 hours of data, as well as the last month's consumption value. So if you just wanted to do a review on what's it been this month to last month, you can see last month. So you're not going back through the your data set. And obviously, yeah, the new one on the smart meters is temperature information, whether it be internal or external ambient temperature. That is also available. Right. So on the on meter integration, I didn't want to do too much on wired communications. There is so many good partners out there, so many good devices already out there, and a lot of you already have your favorite way of working. So whether that's with ISMA, the ISMA IO modules, or the Alvaco range, or Relay Weblog, for example, these are all extremely good and extremely numerous amount of products to mention. So I just wanted to focus on one that we've been working with recently in a more BMS, EMS alike, and one that doesn't have a huge market range, market share within the UK. So this is the EMU M-Center data logger. It's a versatile high-performance energy data logger designed for scalable monitoring and system integration around enabling automated error-free data collection for up to 250 M-Bus meters, and additionally 64 Modbus devices via optional licensing. The key features are integrated high-performance M-Bus level converter for faster commissioning, expandable to Modbus RTU devices via dual RS485 interfaces, built-in data logger for continuous recording, storage, and export of energy data. Supports real-time monitoring, visualization, and reporting via external platforms. Equipped with flexible I/O options for additional system functionality. Compatible with MQTT, BACnet IP, Modbus TCP, and OPC UA. I've never heard of that last one, so you'll have to excuse me. Enables secure firmware updates and device management via web interface, and importantly, designed for ISO 5000 or 50001 energy management compliance for data reporting. This has been a game changer for us in terms of being able to onboard both MBus and Modbus communication. And this includes Ethernet connectivity or optional modem. So yeah. Now on the crux of the presentation, I just wanted to go over the wireless communication. So the first was wireless MBus. As I've mentioned, they provide flexible cable, very flexible systems. The meters can transmit data as quickly as every 60 seconds. So providing you have the infrastructure to meet the requirements, you can get a near real-time solution using wireless MBus. So I just wanted to go through the wireless MBus data flow architecture. First, you have your meters. They send out wireless MBus payloads. Then you include 4 wireless MBus repeaters. Wireless MBus repeaters will then send data on. In this case, I've got a wireless MBus to wired MBus gateway, or a wireless MBus to Modbus gateway. So this then wires directly into a device such as the EMU Center or the Elvaco or any other that you prefer to work with and to integrate with. The key with wireless MBus is that it's very cost effective. So if you have a single building solution, maybe you're doing a retrofit, LoRaWAN would be a great option. It would be great to use. It really would. You can obviously onboard gateways. It just takes a little bit more engineering time. Whereas a wireless MBus, you have the meters, you install the meters, you input the gateways. Maybe you can't get the one of the meters is the coverage isn't good enough for one of the meters, but you just put in another gateway, it creates a mesh network, and then at the head end you have wireless to wired communication. So in this case, wired MBus, easy enough. The protocols map over easily. The WRMTS here can support 450 devices. So you imagine you've got 450 wireless MBus meters. It can be controlled purely by that endpoint. It's a little bit more difficult on wireless MBus to Modbus. It's a newer product to us. But yeah, for the majority of the time, we would recommend wired MBus. Now, LoRaWAN, it is designed for versatility. LoRaWAN seamlessly integrates with both local platforms using on-site gateways and cloud-based device management platforms for virtualized protocol conversion. This flexible architecture enables efficient data routing into BACnet, Modbus, MQTT, and API-driven environments. So typical LoRaWAN data flow architecture is devices, gateways, network server, application server, and then the customer service. So field devices, LoRaWAN enable meters, sensors, and devices for data collection. LoRaWAN network gateways that securely receive device data and handle authentication, forwarding messages to network server, and device management platforms. Now these can be both local and cloud-based platforms. For example, the MileSite UG 67, 65, 56, they all have onboard network service. So integration via local platforms, these require on-site hardware development and maintenance. They do have a higher installation cost in terms of hardware and commissioning cost, limited scalability across multiple sites, works well It does work well for isolated networks or security restricted environments, and it's often necessary for legacy BMS systems. So a typical local platform, local integration would be using either the MileSite or the WattSense integration hub, where you have multiple meters. You onboard the meters or devices or sensors onto the gateway, and then you utilize the BACnet or Modbus conversion from there. Now, integration via cloud-based platforms is a more modern adjustment. So modern deployments will use cloud-based device management platforms to aggregate, process, and translate LoRaWAN data into standard protocols such as BACnet, Modbus, and MQTT without requiring on-site protocol converters. So in this sense, you would have an online platform where you onboard all your devices, gateways, sensors, and then when the hardware is on site, it's all managed by the cloud-based platform. So the device sensor will jump to the closest gateway. So you don't have to. So with local platforms, for example, you can create a gateway fleet where you essentially have one master gateway and then repeaters, or you cut the devices and sensors into, these ones will jump to this gateway, these ones go to this gateway. Whereas classically, cloud-based platforms will allow for, it has a little bit more ingenuity where it will jump to the closest one. Again, really good for preserving a battery life. Eliminates need for on-site integration hardware, lower deployment and commissioning costs, highly scalable across multiple sites portfolios, centralized management, monitoring, and updates. Enables seamless integration with cloud, BMS, and enterprise systems. The difference is the cloud-based platform is going to come with a subscription cost, without a doubt. Integration via local platforms, a little bit more straightforward, especially for the smaller projects where you onboard the devices and sensors to the gateway, convert it to BACnet, and into the controller. You don't have to worry about the ongoing costs. So now we've done all that, I just wanted to go through I'm mindful of the time, so I just want to go through the working method. So selecting the right meter solution depends on a clear understanding of the application and its requirements. Projects can range from small retrofits to large new builds and may involve water, heat, gas, or electric. Key factors such as installation constraints, data needs, accessibility, and end use should guide you to the choice of meter. So, for example, if we just do this in a step-by-step, what utilities are required from the meter? Is it water, heat, cooling, gas, electric, mixed fluid, oil, etc.? What type of installation? Residential, commercial, industrial? Does the type of installation change the type of meter, or at least the approval potentially? And then what's the size and scale of the project? Is it small residential, single dwelling apartment, multi-dwelling residential, or is it up to a citywide utility scale deployment? And then is it required for billing or is it required for monitoring? Now, I did a side-by-side. Accuracy for billing has to be MID approved. Accuracy for monitoring, you always need good accuracy. That's obviously there's no point metering if you don't. But it doesn't have to be legally certified, and there is no, the compliance and no MID requirement. Whereas obviously with billing, it has to meet the legal standards and certification. Data type is for billing usually total consumption. That's all you're billing off. You're not billing off temperatures or anything like that. It is purely the overall consumption, and it has to be billing grade tamper-proof data. Obviously, monitoring. What you are monitoring takes precedent. What information do you want to have the meters tell you, and you can utilize non-MID approved meters for ease of installation. Common one is clamp on ultrasonic meters. So if you have if it is purely for monitoring and you can't cut into the pipe where you can't isolate the system, a clamp on ultrasonic meter will do the job. Typical use for billing is obviously tenant billing, utility charging, cost allocation. On the other side, monitoring, energy management, system optimization, and detection. Mechanical requirements and limitations. This is an important one when when you're realistically looking at what meters to choose, because obviously additional regulatory requirements. Not all meters will have additional regulatory, like RAS approval, for example, is one that most water meters will have if they're designed for potable water. EM 1434 compliance for heat is almost a predetermined. ATEX approval for glass, probably not. Again, that's what really then channels you down. For example, I've just had to find a RAS approved PM40 water meter, and it had to be a particular mag flow meter that was MI001 and RAS approved, and it was So whether I would have selected that from the outset, obviously not, very expensive, but the regulatory requirements will push you down an avenue to find the correct meter that you need for your project. Meter accuracy, performance, and standards. Does a consultant or client request a certain standard? For example, they could come in and say water meters need to be R250 or above, although I doubt a client would request that. If more, it's more so for monitoring low flow rates. Heat meters, again, we've already touched on this. They are typically MID class 2. There are MID class 3 meters out there which are less accurate, but they don't tend to be considered in a lot of instances anyway. And the same with electricity meters. Is it class 1 or 0.5? So yeah, just without rambling on too much, all these points are going to push you down a route of meter, protocol, or integration. The next one that obviously we've touched on is the data required. The key considerations: what's the end user of the data? Is it billing, monitoring, optimization? Does that change how you integrate for it at the top end? What level of data granularity is needed? Again, looking at communications, how they report to either the interface or the system. All of this is again very, very important in terms of what is required, what data will help me. For example, if you've got an external water meter and you're worried about the ambient temperature, you can go down the LoRaWAN route and get a water meter with a built-in temperature sensor. Equally, you can separate that and have a temperature sensor near the meter. So it's all about utilizing hopefully what I've been able to instill today, and just have a bit of a mindful approach on, okay, how can I get the most out of the meters and then make the system work for me. Meter integration, wired and wireless. Identify the types of outputs. So for water meters, you might have ports. Simplify the infrastructure. Pulse to M-bus converters for water, and then M-bus to Modbus converters for water heat, consolidating the multiple meters into a common backbone. And then how are you integrating that with the BMS EMS? Same on the wireless side. Choose what technology is most suitable based on the project requirements. Is it wireless M-bus? Is it LoRaWAN? Assess site requirements. So what's the size and scale of the site? Potential need for repeaters or gateways, and then identification of any gaps and blind spots. Define integration approach, wireless M-bus, integration via local receiver data concentrators. We've been through that. It's very it's very broad with the LoRaWAN. With wireless M-bus, it's very much wireless M-bus into wide technology, whether it be M-bus or Modbus. And LoRaWAN, are you going for local integration, or are you going for a cloud-based integration? And then that's me. So yeah, thank you for listening. Obviously, I think it had just been an hour. So hopefully you've been able to get some useful information from that. If you scan the QR code there, it will link you to my information. So should you have any requirement for any questions on metering or water meters or heat meters in general, by all means take my information and give me a shout.